students, welcome to our online video class of chemistry. I hope all of you are doing well and safe. Previous section we had discussed about significant figures and dimensional analysis. Today we will discuss about law of chemical combination.
We are going to discuss about law of chemical combinations. Law of chemical combination deals with some empirical laws that govern the chemical change. The combination of elements to form compounds is governed by following 5 basic laws. The law of conservation of mass, law of definite proportions, law of multiple proportions, Avogadros law, and finally Gay-Lussac's law of gaseous volume. Law of conservation of mass. This law was put forth by Anthony Lavoisier in 1789. Lavoisier performed his experiment in a closed system. He found that the total weight of the system is not changed in a chemical reaction. He performed the decomposition reaction of mercuric oxide, gives mercury and oxygen. Initially, he take 100 gram of mercury oxide. After the decomposition, 93 gram of mercury and 7 gram of oxygen were formed. In this reaction, the total mass of the reactant is equal to the total mass of the product. That is 93 plus 7 equal 100 grams. And he reached to the conclusion that in all physical and chemical changes, there is no net change in mass during the process. In other words, we can say in all physical and chemical changes, the total mass of the reactants is equal to the total mass of the product. Hence, he reached to the conclusion that matter can neither be created nor destroyed. This is called the law of conservation of mass. This law formed the basis for several later developments in chemistry. Let us take another example. Carbon reacts with oxygen gives carbon dioxide. The mass of one carbon is 12 and mass of one oxygen is 16. Then for 2 oxygen it becomes 2 into 16, 32. Total mass of the reactant equal 44 grams. And it react together to form carbon dioxide, which is also 44 grams. Hence, in this reaction, the mass of reactant equal to mass of product. Next law is law of definite proportions. This law was given by a French chemist, Joseph Proust, in 1797. And this law states that if a compound is broken down into its constituent elements, the masses of the constituent will always have same proportion, regardless of the quantity or the source of the original substance. Law of definite proportion states that a given compound contains exactly the same proportion of the elements by weight. Proust worked with 2 samples of cupric carbonate, one of which was of natural origin and other was synthetic origin. He found that the composition of elements present in it was same for both the sample. It is shown in this table. Natural sample copper 51.35% and carbon is 9.74%. Oxygen is about 38.91%. In the case of synthetic sample, it is also same. Copper is 51.35 and carbon is 9.74 and oxygen is 38.91. Thus, he concluded that irrespective of the source, a given compound always contains same elements combined together in same proportion by mass. The validity of this law has been confirmed by various experiments. It is sometimes also refers to as law of definite composition. Let us take another example. Water. What is the chemical composition of water? H2O. If water obtained from any source like a river, rain or tap and from any country is always made up of the same element, that is hydrogen and oxygen. In all cases, 2 gram of hydrogen combined together with a 16 gram of oxygen. Hydrogen and oxygen combined together in same fixed proportion, that is 1:8 by mass. From this we can say water H2O is always found to contain only 2 elements, hydrogen and oxygen, combined in a definite mass ratio of 1:8 irrespective of its source. Similarly, sodium chloride NaCl from whatever source will always contain 23 gram of sodium and 35 gram of chlorine. Law of multiple proportion. This law was proposed by Dalton in 1803. According to this law, if 2 elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in the ratio of small whole numbers. Let us understand the law of multiple proportion using an example. Hydrogen combines with oxygen form 2 compounds, namely water and hydrogen peroxide. Here, how water is formed? Water is formed by combining 2 gram of hydrogen and 16 gram of oxygen. And hydrogen peroxide is formed by combining 2 gram of hydrogen and 32 gram of oxygen. From this you can observe that the mass of hydrogen is fixed, but the masses of oxygen is different. One is 16 gram, other is 32 gram. And here the masses of oxygen, that is 16 gram and 32 gram, which combine with fixed mass of hydrogen, that is 2 gram, bear a simple ratio, that is 16:32 or 1:2. Gay-Lussac's law of gaseous volume. This law put forward by French chemist Gay-Lussac in 1808 and established an interesting volume-volume relationship between the volumes of reactants and products. According to this law, when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all gases are at same temperature and pressure, or under constant temperature and pressure. The volume of gaseous reactant bear a simple ratio between themselves and volume of the products if gaseous. An example, the reaction between hydrogen and chlorine gives hydrogen chloride, and the ratio of the volumes of hydrogen, chlorine and hydrogen chloride is 1:1:2, a simple ratio. Another example is 100 ml of hydrogen
combined with the 50 ml of oxygen form 100 ml of water vapor. Volume of hydrogen and oxygen combined, that is 100 ml of hydrogen and 50 ml of oxygen, bears the ratio of 2:1, that is 100 divided by 50. Ratio is 2:1. And the ratio of volume of hydrogen, oxygen and water is 2:1:2. From this, we can conclude that at constant temperature and pressure, the volume of gaseous reactants. What are the gaseous reactants here? Hydrogen and oxygen. Bears a simple ratio between themselves, that is 2:1. And also with the volume of the products, if gaseous. What are the ratio of the volumes of hydrogen, oxygen and water? That is 2:1:2. Thus, it appears that law of gaseous volume is actually law of definite proportion by volume. Avogadros law. It was proposed by Avogadro in 1811. It states that equal volume of all gases at the same temperature and pressure should contain equal number of molecules. For an example, if equal volume of different gases are held in separate containers under similar conditions of temperature and pressure, then each container will contain the same number of molecules. The total mass of each gas in the container may differ from. Here we take equal volume of different gases such as hydrogen, nitrogen and oxygen. Similar conditions of temperature and pressure. Temperature is T Kelvin and pressure is P atm. Then each container will contain same number of molecules, that is N. Avogadro made a distinction between atoms and molecules, which is quite understandable in present days. If we consider again the reaction of hydrogen and oxygen to produce water, we see that 2 volumes of hydrogen combines with 1 volume of oxygen to give 2 volumes of water without leaving an unreacted oxygen. Note the figure. Each box contains equal number of molecules. Avogadro could explain the above result by considering the molecules to be polyatomic. If hydrogen and oxygen were considered as diatomic as recognized now, then the above results are easily understandable. However, Dalton and others believed at that time the atoms of the same kind cannot combine, and molecules of oxygen or hydrogen containing 2 atoms did not exist. I hope you might have understood what we learned today. We learned today about laws of chemical combinations. What are the 5 laws of chemical combinations? Law of conservation of mass, law of definite proportion, law of multiple proportion, Avogadro's law and Gay-Lussac's law of gaseous volume.